So today we're reviewing absolute value and how to work with absolute value when your x is inside your absolute value sign as a problem. This is going to be a couple problems on your Chapter 3 quiz and test. So as we're working on these, we're going to go through 3 different examples, increasing in difficulty, actually 4 maybe. So let's take a look. Our first example is the absolute value of 3x minus 5 equals 13. Now, what we're looking for is we're looking for the numbers inside the absolute value sign, which is 3x minus 5. We need that to equal to 13 because the absolute value of 13 is 13. However, remember that absolute value is the distance from 0 on a number line. So if we can get what's inside that absolute value to be negative 13, the absolute value of negative 13 is also 13 because it's once again a distance, and negative 13 is also 13 spots away from 0. So that means for the majority of these, not all of them, but for the majority of them, there is going to be 2 answers. So we're going to have one where we set what's inside the set of parentheses to 13 and also set the inside of the parentheses to negative 13. Okay, there could also be 1 or there could be 0 if there's no solution. We'll talk an example of those as well. So we're going to go ahead and take this and we're going to look at just what's inside our absolute values. We're going to take those absolute values away. And so we're going to have 2 equations, 3x minus 5 equals 13 and 3x minus 5 equals negative 13. Now we're simply going to solve for x. For our equation on the left, we're going to add 5 to both sides, which leaves us with 3x is equal to 18. We're then going to divide both sides by 3, and x is equal to 6. We're now going to solve the equation on the right. We're going to add 5 to both sides, and that gives us 3x is equal to negative 8. Divide both sides by 3, and x is equal to negative 8/3. So these are our 2 answers. X is 6 or x is negative 8/3. Let's go ahead and look at another example. This example is the absolute value of negative 2x minus 1 minus 3 equals 9. Now, we cannot start solving for our absolute value until all that's left on one side of the equation is just the absolute value. So before we start splitting it into 2 different problems, we need to go ahead and get everything to the other side of the equation. So we have that minus 3 that's stopping it from being isolated. So we're going to go ahead and we're going to add 3 to both sides. Now we have the absolute value of negative 2x minus 1 is equal to 12. Now that on one side we just have the absolute value, now we're ready to switch it into 2 possible answers. So our first one is negative 2x minus 1 is equal to 12, because if we get that inside to be 12, the absolute value of 12 is 12. And negative 2x minus 1 is equal to negative 12, because if we can get that inside to be negative 12, the absolute value of negative 12 is 12 as well. So we're going to go ahead and solve. We're going to add 1 to both sides. That becomes negative 2x equals 13. Divide both sides by negative 2, and x is equal to negative 13/5, also known as negative 6.5. You'll be able to leave it as a fraction or as a decimal. For our one on the right, we're going to add 1 to both sides. Negative 2x is negative 11. Divide both sides by negative 2, and x is equal to 11 halves, or positive 5.5. So our answers for this problem is negative 6.5 or 5.5. Now remember, the reason we show this example is you need to make sure that you don't split it up until you've isolated the absolute value on one side of your equation. Here's our third example. Negative x plus 5, the absolute value, plus 4 is equal to 3. So we're going to isolate the absolute value. We're going to subtract 4 from both sides. And we have the absolute value of negative x plus 5 is equal to negative 1. Wait a minute. Negative 1? Can I have a distance that's a negative number? No, I can't. So if you've isolated the left-hand side and you look at the right and it's a negative number, you are done with the problem. There is no solution because, once again, absolute value is a distance and we can't have a negative distance. So if you've isolated your absolute value on one side and you're left with a negative number on the right, then your answer is no solution. However, be careful. Once again, you can't look at that number and make that determination until you have completed that isolating of the absolute value on one side. So once again, when the absolute value is alone on one side, the answer cannot be negative on the right. It's important to remember. Our last example here is example number 4. So our fourth example has a lot of stuff to do before we can break it into 2 problems. We have 3 times the absolute value of x plus 2 minus 4 equals 11. So remember, a number outside an absolute value means to multiply, just like a number outside a set of parentheses. So we're going to go ahead and add 4 to each side, and that leaves us with 3 times the absolute value of x plus 2 and 14 on the other. Now, we're not distributing over absolute value. We never distribute over absolute value. So the way that we're going to get rid of that 3 times is we're going to do the opposite of multiplying by 3, which is dividing by 3. So we're going to divide both sides by 3. What we have now is the absolute value of x plus 2 is equal to 5. Now we've isolated our absolute value. We have a plain number on the other side, and it is positive, so we know we're going to have 2 answers. So we're going to go ahead and set up our 2 options. X plus 2 is equal to 5, and x plus 2 is equal to negative 5. Once again, it's because what we want inside our absolute value. If it's 5, the absolute value of 5 is 5, or if what's inside is negative 5, the absolute value of negative 5 is 5. So let's go ahead and solve. For x, we're going to subtract 2 from both sides, and we have an x of 3. And for our other one, we're going to subtract 2 from both sides, and our other option, x is negative 7. So our answer is x is 3 or x is negative 7. When we plug that into our equation, we will get the answer on the right. We're going to go ahead and get some practice, as always, ladies and gentlemen.